Assalamualaikum. Hi class, welcome back. Welcome back to my video. We're going to talk about hypothesis testing for the differences between two population means. All right. So in this video, we're going to do exactly the same thing that we did on my chapter 3.2 video, which is we're going to do hypothesis testing using traditional approach by using all the 5 steps in doing the hypothesis testing. So if you think that you're still not strong for chapter 3.2, if you think that you still don't understand how to conduct the hypothesis testing, how to do all the 5 steps, then I would suggest that you stop watching this video, you go back to chapter 3.2 and do a few exercises, okay? And if you think that you understand all the 5 steps, then only you proceed to watch this video. Okay, so yeah, don't worry, okay? Make sure that you understand all the 5 steps before you come into this video. So if you think you understand all the 5 steps already, so let's get started with chapter 3.3. Okay, so in this video, I'm going to show you what are the test statistics formula for the case of a claim that involves two population means, okay, a claim that involves the differences between two population means. So you can no longer use the test statistics value that you learned in chapter 3.2. So that formulas are specifically for the claim that involve only one population mean. So now in this video, I'm going to show you 5 different formulas to calculate test statistics for the case of differences between two population means. Alright, so for example, let me just create a new claim by Pak Mail. So maybe Pak Mail claimed that the average amount of milk produced by breed A is less than breed B. Okay, you see here, this is a statistical hypothesis. Why do I say that? Because the claim involves average, which is population mean. And then this claim involves two populations, which is breed A and breed B. So in other words, what Pak Mail needs to test is that, is it true that the population mean amount of milk produced by breed A, I'm sorry, this is a mistake, okay? This is supposed to be less than, okay, less. Okay, right, so in other words, Pak Mail needs to test, is it true that the population mean amount of milk produced by breed A is less than the population mean amount of milk produced by breed B? Okay, so this is about the differences between the population mean of breed A and breed B. So in statistical notations, okay, I can rewrite this claim in statistical notation as the population mean of breed A is less than the population mean of breed B. Right? As simple as that, okay? So this involves two population means, and the expression used, okay, the mathematical expression that I use is less than or smaller than. Okay, so now that you have written the claim in statistical notations, when the claim involved differences between two population means, okay, it's better for you to rearrange your statistical statement here, rearrange in a way that all the parameters is on the left hand side. Okay, you can see here mu A is on the left hand side and mu B is on the right hand side. So it's better for us to rearrange, and we move mu B to the left hand side. So it will be like this. Okay, mu B, you come to the left hand side, it becomes minus. Okay, so here, betul tak? Ini macam linear algebra. Kan? Pindah jadi negatif kan? Okay, so then on the right hand side, you will have 0 lah, because there's nothing on the right hand side after you move mu B to the left. So right hand side will be automatically 0. Okay, so yep, this is the statistical statement. Okay, this is the statistical notations to represent Pak Mail claimed the average amount of milk produced by breed A is less than breed B. So the statistical notation is mu A minus mu B is less than 0. Okay, it's the same thing, right? It is the same thing, correct or not? Now, so next, what should we do? So the first step of the hypothesis testing, next Pak Mail should determine lah whether this is a two-tail test, right-tail test, or left-tail test. So this is an example of condition which the claim is concerning about the differences between two population means. Okay, so excuse me. All right. Then in this case, Pak Mail will have a left-tail test. Am I right? It will be a left-tail test because the expression used is a less than expression, so it belongs to the left-tailed test. So Pak Mail will have H null mu A minus mu B greater than or equal to 0, H1 mu A minus mu B less than 0. So in this case, all right, the hypothesized, okay, mu naught here is the hypothesized mean difference, okay? Mu naught in this chapter is called the hypothesized mean difference. So the hypothesized mean difference here is 0. Sorry, so mu naught is equals to 0 because 0 is the value that appear in your claim. Okay, so yeah, so this is how your two-tailed test is gonna look like for differences between two population means. This is how your right-tailed test is gonna look like. So always, okay, put the parameter on the left-hand side and just leave the hypothesized mean difference on the right-hand side of this equation. Formula. So now let's take a look at the 5 formulas. Okay, let us try to stay focused, okay, including me. There are 5 formulas to calculate the test statistics for the case of two differences between two population mean, and what we're talking here is for independent samples, okay, for the case of independent samples. All right, so let me just rephrase that. If your claim involves the differences between two population means for the case of independent samples, these are the 5 formulas that you need to choose from in order to calculate test statistics, which is the step 2 in your hypothesis testing. Okay, so the conditions in which to use each formula is exactly similar as chapter 2.3. Okay, so the first formula you use when the sigma square are known, both sigma square are known, then you use the first formula, exact test. If your sigma square are unknown, you have 4 different formulas to choose from. So sigma square unknown, assuming population variances are equal, sample size more than 30 is this one, sample size less than 30 is this one. Okay, sigma square unknown, assuming that the population variances are different, sample size more than 30 is this one, and sample size less than 30 it is this one. Okay, so yep, you need to be careful about this. Okay, make sure that you understand which case is given to you in the question and choose the correct formula. So I think this is the only new thing that I need to teach you in this video. This is your new learning point, which is 5 different formula to choose from. All right, so let's take a look at the first example here. So here they give you about brand 1 and brand 2. What is this about? The overall distance in meter traveled of a golf ball is tested by hitting the ball with the golf stick. 10 balls selected randomly from 2 different brands are tested, and the overall distance is measured, and the data are given as follows. So this is the raw data. Okay, you have the first sample from brand 1 and the second sample from brand 2, and each sample has 10 data values. So the sample size is 10 for each sample. Okay, so here obviously brand 1 is one population and brand 2 is another population, so therefore we can be confident that this is the case of independent samples. Okay, these 10 data were measured from this 10 balls of brand 1. These 10 data were collected from a different sets of balls from brand 2. So these are 2 different populations. Okay, so this is the situation given to you. By assuming that the data for both brands are normally distributed with different population variances, okay, take note on that. Can we say that both brands of ball have similar overall distance? Question mark. Use alpha 0.05. Alright, so this is the question, class. You might notice that there is no hypothesis testing mentioned in this question at all. Nothing, okay? But they do ask you, can we say that both brands, so they are asking for a certain claim, okay, they're asking for you to tell whether this is true or not. So the only way to test whether a certain statement is true or not is by using hypothesis testing. So this is an indirect way to ask you, okay, to conduct hypothesis testing. Alpha is given 0.05. Okay, so first now let us try to understand variable sample population. Okay, so what is the variable in this question, class? Okay, please look at the question. What is the data being collected? What is the data being recorded? What is the data being measured? Can you see it? Is this one, okay? Overall distance is measured. So the variable here is overall distance of golf ball from brand 1 and also brand 2. So these two variables were collected from both samples, okay? And then, so you have 10 samples from brand 1, 10 samples from brand 2. So the population should be all balls from brand 1 and all golf balls from brand 2. Alright, so that's it. Alright, now what else? What else can we get from this question? From the given data sets here, you can easily use your calculator. You can use the statistical function in your calculator to calculate the sample mean and sample standard deviation for both brands. Okay? Yeah, why don't you just pause this video and try and get all this value, okay? Okay, moving on. Next, what else do you have? Different population variances. Okay, so this statement tells us that we should assume that sigma square 1 is not equals to sigma square 2. So if you see this statement, then you can be sure that this is the case of independent samples, and then it is the case of sigma square 1 and sigma square 2 unknown. Or else they wouldn't give you this statement. So this is a hint, okay? This is a hint given to you in the question. This is independent samples, population variances unknown, and assuming different population variances. And finally, they also give you the alpha value, which is 0.05. So once you have extracted all this important information from the question, now you are ready to test, okay, whether is it true or not true that both brands have similar overall distance. Ready? Bismillahirrahmanirrahim. Let us start with the first step, okay, which is to formulate the claim, okay? Both brands of ball have similar average overall distance. So number one, from the word similar, you will use the mathematical expression of equals. And from the word average, you know that this is involved population mean. So since it is mentioned both brands, so there should be two population means, okay? One is for brand 1 and another is for brand 2. So based on this info, I can construct my statistical notations, which is mu1 equals to mu2, right? And then let's move mu2 to the left hand side. So you will get mu1 minus mu2 equals to 0. Okay, great. Next, we need to determine whether this claim, is it H null or is it H1? Okay, is it a null hypothesis or is it an alternative hypothesis? So you need to refer to the slide note table, page 7, is it? Okay, based on that page, okay, you will determine whether this is H null or H1. So some of you might have memorized that table already. So the answer is H null. Okay, so this statement will go to H null. And so you can construct the other statement, H1, which is exactly the same but use a not equal sign expression. So this is your first step, class. Okay, the first step is done. Okay, so now we can proceed to the second step, which is to calculate the test statistics value based on the conditions given to us. So we have discussed earlier, this is a sigma square unknown, assuming population variances are different. And if you look at the sample size of both brands, both are less than 30. So which formula should you choose? Let's take a look at the 5 formulas again. Unknown, different variances, less than 30. It is this formula, class. Oh my god. Okay. Alright, so this is the formula. So please, when you want to calculate the test statistics value, make sure that you copy, okay? You write down the formula carefully, okay? Don't leave out any element of the formula. Right, so yep, just use this formula to substitute the calculated sample mean and substitute the sample centration, also the sample size. So mu naught here is the hypothesized mean difference. So what is our hypothesized mean difference here, class? The hypothesized mean difference here is 0, okay, because 0 is the number that appear in your first step. Okay, so you pun calculate lah, okay, calculate and you get the value, which is here t-test. The notation for your test statistics in this case is t-test. So t-test equals to 2.5061. Yep, why don't you just pause this video and then try to calculate this, alright? The formula is a bit complicated but not too hard, okay? I'm sure you can get this. Okay, so 2.5061, that is the test statistics value. Next, we're going to do step 3, which is to establish the critical value, right? And also the rejection region. So by looking at your step 1, so this is a two-tailed test, am I right? So this is a two-tailed test. Therefore, you will have this kind of rejection region, okay? Left, right, and acceptance region in the middle, okay? And also, what is the critical value that will separate your acceptance and rejection region? So in this case, your critical value should come from the t-distribution table, okay? Because in step 2, your test statistic is a t-test, therefore, the corresponding critical value should be a t-critical value, right? So since this is a two-tailed test, it is alpha divided by 2, okay? It's a two-tailed test, that's why alpha should be divided by 2 and nu. Alright, okay. So this should be the critical value formula, okay? On the left hand side, your critical value should be negative t alpha over 2 nu. On the right hand side, your critical value should be positive t alpha over 2 nu. Get it? So now alpha is given, right, in the question just now, 0.05. So alpha divided by 2 should be 0.025. But what about the degree of freedom here, nu? What is the formula for nu? So if you look at the list of formulas, you will see that nu for this formula, okay, the nu is given by this very elaborated formula. Masya Allah, dugaannya. Okay, don't worry, you can do this, okay, slow and steady, alright? So please learn up how to use this formula, and yes, of course, you can just PM me anytime if you can't get the right answer for this formula. Okay, now, so we're going to use this formula to calculate the degree of freedom, okay? To calculate the degree of freedom, so substitute all the values accordingly. You should get 17.3440. So according to the rule here, we need to round down, okay? You need to round down to the nearest whole number. So from 17.3440, if you round down from 17, it'll be 17, not 18, but 17. Okay, so the degree of freedom here is 17. Therefore, your critical value is t 0.025, 17. Okay, make sure you can find this value in your stats table. 2.1098. All right, so then you can draw your rejection acceptance region separated by the criticals value, okay? Negative 2.1098 on the left hand side and positive 2.1098 on the right hand side. Okay ke? Okay kan? Okay, so this is a two-tailed test, that's why the critical value, the rejection region looks like this. Okay, so done on that part. And then step number 4, you need to decide, okay, what about the H null? To reject or not reject H null. So let's take a look. Why do we reject H null for this example? It's because the t-test, which is 2.5061, so this is from your step 2, the t-test here falls in the rejection region, am I right? The t-test is bigger than the positive critical value. So in a two-tailed test case, if your t-test is greater than the positive critical value, it means your test statistic falls in the rejection region. Betul tak? It is somewhere here. So it is in the rejection region. That's why we need to reject H null. Okay? Reject H null. And then, and finally, in step 5, we need to make a conclusion, right, regarding the claim. Okay? You need to refer back to your step 1, okay, in order to do the conclusion. Reject H null, okay, reject H null. So maksudnya, this first statement is not true from this hypothesis testing. The evidence, okay, the statistical data showed that the test statistics suggest that we should reject H null. So if we reject H null, that means H1 is true. Okay, H1 should be supported, H1 should be accepted. Okay class, so what is the conclusion? So the conclusion is not about H1, it's not about H null. The conclusion is about the claim. So when you reject H null and claim is at H null, so rejecting H null also means you reject your claim. Okay, so when you reject H null, consequently you are also rejecting the claim, because in this case claim is at H null. Because of that. Okay, so nasib dia lah, dia duduk tang situ, lepas tu dia duduk dekat H null, lepas tu H null kena reject, lepas tu dia sekali kena reject. Macam tu lebih kurang. Okay, so because claim is at H null and the decision say reject H null, so therefore we also need to reject our claim. So that's the conclusion for this question class. Okay. So at alpha 0.05, there is sufficient evidence to reject the claim that both brands of ball have similar average overall distance. Done. Finish. Okay, these are the 5 steps to conduct hypothesis testing. So you're gonna be repeating the same 5 steps throughout this chapter, but perhaps the only thing that will be different is the formula to calculate statistic value. Okay, so in this chapter you have 5 different formulas to choose from. 5 different formulas. So how's that? Right, so come on. If you have any question at this point, okay, if you have any question, PM me immediately, alright? So that is all for this video class. Please read on example 3.4. So there's a solution given to you in your slide notes. Alright, so why don't you, before you look at the solution of example 3.4, why don't you try to solve this on your own? And then you look at the solution. Okay, so, but maybe I need to discuss about the claim, okay? For this example, I do need to discuss to you about the claim. Here, the claim says that the mean of alloy 1 exceed the mean of alloy 2. So, mu1 greater than mu2, am I right? Mu1 greater than mu2, but by more than 0.5. So, this additional info here, okay, exceed by more than 0.5 will give you this as your statistical statement for your claim. Mu1 minus mu2 greater than 0.5. Kenapa? Why? Okay, greater than because of the word exceed, and 0.5 because that is the hypothesized mean difference given in the question. So this is how you should write the statistical notations. Mu1 minus mu2 greater than 0.5. Okay, alright lah. Just give it a try. Okay, give it a try. Try to do step 2, 3, 4, 5 on your own. So in this video, I have discussed the first step. So I want you to proceed to try step 2, 3, 4, 5 on your own without looking at the solution. Give it a try. Okay class, that is all for this video. Thank you so much for watching. I'll see you in my next one. Bye.